Can everyone hear me all right? Okay. I'm going to try not to turn my head too quickly or this will fall off, so bear with me. So this is normalization. This is an intro to normalization. If you're already familiar and you're looking for some advanced discussion, this might be a little bit beginner for you. It won't offend me if you want to go see another talk. So this will be an introduction to normalization. Also, I'm from the US, and I tried really hard to correct all the spelling of normalization for you, but let me know if I missed one. Okay. So starting out with who am I? My name is Beth Tucker-Long. I'm the editor-in-chief of PHP Architect magazine. I also run a freelancing company, so I do freelancing on the side. I did bring a couple of issues of PHP Architect. If you're not familiar with it, stop on by up front here afterwards. I have 4 issues. If you'd like an issue to take home, I have some extras in my bag. Please don't take the 4 that are on the table. Those are my very last copies. So don't take those, but if you'd like an issue, let me know. I'm also a stay-at-home mom. This is my family, and I'm also a user group organizer. I hope you are all familiar with the PHP London user group here in town, but if you are not familiar with a user group in your area, I strongly recommend you take a look and find one. User groups are amazing. There's so much learning goes on there. It's a great way to network with people, get support on things you need, and just really grow as a developer. If there's not a user group in your area, then I strongly recommend that you start one, and I would love to help you start one. Don't worry, we're not going to send you off on your own. We would love to help you start one, so just get in touch with me afterwards. A small disclaimer before we get started besides the spelling of normalization. The databases that I'm showing you here are for example purposes only. There's a lot of things wrong with these databases, so just bear with me. They're strictly for the example purposes so we can show sort of the point of normalization. So what exactly is normalization? Well, normalization generally deals with relational databases, and it's a way to sort of organize those databases so that we are not having a lot of redundant data, so we are not having a lot of dependency of the data on other things. And when we go in to modify the data, we don't have to worry about finding it in multiple places to modify it. Especially when you're dealing with a very large database, you don't want to have to go through multiple tables and update the same data multiple times, because you could run into collisions. We don't want to have some places updated and other places not. We want to keep our data consistent, and we want to maintain the integrity of our data. So when did normalization start? Well, normalization has been around for a very, very long time. So it was started basically in 1970 is when it officially became I guess a buzzword of sorts. The theory started evolving long before 1970, but in 1970 is when the paper was published that first sort of officially defined the first normal form of normalization. The second and third normal forms came 1 year later, and they were introduced by a man named Edgar F. Codd, who is generally credited with creating the idea of relational databases. Now, there are more normal forms than just the 3 that we're going to cover today. There's also 4th and 5th normal form, and there's several other forms as well. We are only going to cover the first 3 today just for simplicity's sake, but I do have some more resources later on in my slides, and you will be able to do some more research if you'd like to know more about those other forms. So very briefly, let's start with the first normal form. So the first normal form says each record has the same number of fields. Now generally in our modern relational databases, that one is already a given. That's just built in for us. Not having any duplicate records. That's another one that generally is easy to take care of. The third item is each set of data must have a unique identifier. Now this does not have to be a numeric ID. It could be the name, it could be a word, it could be even a set of fields. So you can actually use multiple fields as your defining key. It doesn't have to be a single field. Generally though, what most people do is they have an ID field that auto increments, it's numeric, and it just automatically gives you the next highest number, so it's always unique. It's an easy way to do it. The last item to be first normal compliant is to have only 1 value per field. That's another one that we oftentimes do, but not always, so another one to take note of. So let's take a look at what this actually looks like in practice. So here we have a sample database table. It's a bus and train. It's an imaginary company. Don't try to line it up with any real city. So it's an imaginary train company that also runs buses. And so we have some information in the database about which lines have buses versus trains. You'll notice the red line is just bus, the blue line is just train, but the yellow line has both train and bus. So going through with our first normal form here, each record already has the same number of fields just based on the relational database that we're using. We don't currently have any duplicate records. If we look here, even though we have 2 records for the yellow line, you'll notice that they are not identical. So one is a train record and one is a bus record, so they're not identical, even though almost all of the information is identical for this record. So the third item is that each set of data must have a unique identifier. So our table is currently lacking that. So let's take a look at how we could add this. Right now, as I said, we don't have to necessarily use a number. We could use, say, the line name. Now, right now, we can't use the line name because we have 2 different yellow line records. So what we could do is we could combine those 2 yellow line records into one. So we have train and bus, and now we have red, yellow, and blue lines, which are now unique. However, that's not always a good solution and requires you to always make sure that that's unique. Every time you go in and add another line, you have to double check. It's not always a good solution. So we can add an ID field, and that ID field, as I said, if we set it to auto increment, we'll always get a new number, and that will stay unique for us. So now we have our 2 yellow line records back, and we have a unique ID. However, we're not quite up to the first normal form yet. We still need to make sure we have only 1 value per field, and those values need to be consistent. So let's start with the values being consistent. So right now, what that means is in the line name field, we only have line names. That's fine. So our data is pretty consistent. If you look at each field, we're very consistent about what data is in that field. However, we do have several fields that have multiple values in them. For instance, the district column, if you look at district, we have district 1 and 2, 2, 3, 4, and 5. So those are multiple values. Even though they're all districts, it's multiple districts in one field. So we're not going to be able to comply with the first normal form until we take care of that. So we can stretch our table out. Now we have 12 records instead of 3 or 4. So we have a lot more records, but we are now meeting the first normal form. You'll notice now that all of the fields only contain 1 value. Each of the records, or each of the columns, each of the columns contains only 1 type of data, so we're consistent in which data is being displayed in that column. We have a unique identifier, and we have the same number of fields in each record. First normal form is pretty common to have, but generally people don't stop there. Generally they go all the way to the third. So let's talk about second normal form. Second normal form must meet all of the requirements of the first normal form. And in addition to the first normal form requirements, the first normal form requirements being each record has the same number of fields, no duplicate records, each set of data has to have a unique identifier, and only 1 value per field, and values must be consistent. So we're adding to that list, we're going to add everything must relate directly to the key or the main value. Now, as I said, the key doesn't have to be a numeric value. It could be the line name, or it could be any other type of data that's unique to your table. So in this case, it doesn't have to relate directly to a numeric key. It has to relate directly to whatever is the most important piece of data for your table. So taking a look at our schedule here, probably the most important piece of data here for us would be the lines. Everything sort of relates back to the line. So as far as the red line goes, the transportation type relates to the red line, the district that it's in relates to the red line, and so on. So that's sort of our key piece of data. Now, we want to make sure that everything relates directly to that. Now, when we look at this, yes, transportation type relates directly to that. District relates directly to that. But the district office relates to the district, not necessarily to the line. So that is not relating directly to our key. So we need to pull that district information out into a separate table to comply with second normal form. So here you can see what I've done, and I apologize that the headings on the columns are wrapping. As we get more and more tables, it gets harder and harder to fit them all on one slide. So I apologize about the weird word wrapping at the top there. But what we have here now is we have a table which contains our line-specific information, including the district. And then we have a district table, which now has all the district-specific information. this will comply with second normal form. Now what I've done here is, since district already had a number, we had a district number originally, I did not create a second ID number for that because we already have a unique number for the district. So the foreign key in the first table, district, relates to the district field in the second table. So that's how we'll create the relationship between the two. We'll relate those two tables through the district numbers. Okay, so now we're second normal form compliant. Going to third normal form compliant, again, we have to meet all of the first normal form requirements, all of the second normal form requirements, and now we're going to add no transitive dependencies. Now, a transitive dependency is going to be any time a non-key value is dependent upon another non-key value. And again, when I say key, I don't necessarily mean the ID field, it's whatever is the key piece of data in our table. So what does that mean for our table? Well, taking a look at our table, we have our line table. It has all our line information, and we have our district table. Now in the line table, we have transportation type, which relates directly to the line, and we have the district, which relates directly to the line. So that table is compliant with third normal form. Our district table, however, we have the district office relates directly to the district, and then we have a district manager that relates to a district, but then we have an extension. The extension doesn't relate to the district, that's the phone number for the district manager. So that relates directly to the district manager. So what we have here is we have a non-key value depending on another non-key value. So what we need to do is pull those out. So we are going to pull out the district managers and make those our key in a new table. And now our extension, the phone number, now relates to that key value in the table as opposed to a non-key value. So now our red line table, everything relates directly to the red line key. And in the district table, everything relates to the district key. And in the district manager table, everything relates to that district manager. So what we've done is we've split it out. We have 3 tables now, so we have more tables, more records. But what we do have now is third normal form compliance. So let's go through this one more time. So let's take a different example. So once again, to get to third normal form, these are the steps. So all 6 of these, the first 4 are first normal form, number 5 brings us to second, and number 6 brings us to third normal form. So let's say we have a database with food in it. So we're going to make some food. I'm glad I'm after lunch and not right before. So let's take, for instance, our fruit salad. So we have a fruit salad, we have a description of the fruit salad, and even though it's split onto 2 lines, this is all one database, or one table, pardon me. So to get this, let's start with first normal form again. So looking at first normal form, we sort of have a key with fruit salad, cheese display, and Havarti on rye. But let's say in the future we add another fruit salad. It's still called fruit salad but has different ingredients, so that's really not going to work for us for a primary key. So we add an ID column. The next step is we have to make sure that all of the fields all of the records have the same number of fields. We have that. Each of the fields only contains one set of data, and we are failing at that pretty miserably here. So we're going to split out our ingredients into multiple fields. So again, I have not split them out into multiple tables. What I've done here is just added more fields to the record. It's not necessarily an ideal solution, but it does meet first normal form. So right now we have our descriptions, we have our ingredients, we have ingredient 2, and so on. Now this isn't going to work necessarily very well because we might have a dish in the future that has 3 ingredients, or 4, or 27, and we don't want to have to keep changing the structure of our table every time we add a new ingredient. So even though we have met first normal form compliance, we may want to still split this out a bit further and add in 2 more tables here. So what I have now is I have the dish table, where we have which dish we're going to create. I have an ingredients table that lists the ingredients, and now I have a third table to relate the 2. So now it doesn't matter how many ingredients a dish has, we don't have to change the structure of our table. I do want to point out, though, that as I said, both of these meet the first normal form. So normalizing to second and third form, we're going to get in here with our tables. We're pretty close, but what we need to do now is split out the preparation method. So here we have the preparation method in with the ingredient. But the preparation description relies on the preparation method, not on the ingredient name. So what we need to do is split those out. So now we have 4 tables. So we're going to have our dish. We're going to have the ingredient relation table and the ingredients table. And then we're also going to have a preparation method table. Now you'll notice that I didn't create another table for matching up the preparation method with the ingredient. And that's because for our purposes, I'm assuming that each ingredient will only have one preparation method. However, that's not very likely in the real world. So in the real world, you'll probably want to have a 5th table that will then relate the ingredients to the preparation method. That will also decrease some duplication and things like that. So I have a few slides in here with some normalization resources, some articles you can look at. This is for later when you download my slides. But there are some really great articles out there. Of course, the Wikipedia definition to get you started, but there are a lot of great articles. There's even some YouTube videos if you would like to watch someone normalize a database, depending on which way you prefer. So there's articles to read, videos to watch, a lot of great resources. Now, normalization is great, but eventually you get to a point and you might run into a situation where normalization does not help. Okay? The goal is to make things easier, make things more stable, but sometimes normalization can cause issues. So when could normalization hurt us? Well, normalization can get into a problem where suddenly we now have so many joins to get these tables back together that we're taking a major performance hit. Now, normally what you want to do is try to create an index or try to create a view or something, whatever database you're using. Try to create some sort of index where you're already adding the data back together, denormalizing it of sorts, and then querying off that denormalized form, but still maintaining the stability and the integrity of the data in normalized tables in the background. However, in some cases, that may not be enough. And just to give you an idea, so we went from a select star from dish as our first query to this huge query down here with 3 left joins. So it really went from a very, very simple query to a very complicated one very quickly. Now there is quite a big disagreement about whether or not that's just laziness on our part if we want to denormalize to not have such complicated queries, or if it really is worthwhile to denormalize to simplify things. And that's a decision that you and your team have to make. I would venture to say that there's no correct answer in that argument based on how many people are staunchly on one side or the other. But evaluate with your team. See if the time you're spending making sure that the queries are going to run quickly, creating the views every time you need a new query, is that worth the performance hit that you're taking by denormalizing? Additionally, if denormalizing your data isn't really giving you much more security or saving you from the risk of updating some data and not others so your data gets out of sync and so on, then the performance hit may not be worthwhile. However, sometimes the performance hit is worthwhile if you are gaining that level of security in your data. Another reason that normalization might not be necessary. And another reason that normalization might not be necessary is if your data is not going to change. One of the major reasons to normalize, as I said, is to make sure that when you update your data, when you insert data, that everything stays in sync. All the tables stay in sync. All the instances of that piece of data stay in sync. So you only want to have to update it in one place, because if you have to update it in 10 different places, if that takes a while, if it has to get queued up and done later, things can get out of sync very easily. Now, if you are archiving records, let's say you have some historical financial data that can't be changed ever, then perhaps normalization is overkill because you're never going to be changing that data. So there's no opportunity for it to be out of sync. In that case, you might want to go with the better performing route and have a denormalized table to make it easier to search. You don't have to keep creating more views every time you need a different type of query, and so on. So normalization is very good, but there comes a point when normalization may not be good for you as well. So I also have some denormalization resources, some articles for you to read later. These are some people who have talked about places, for instance, where they're working. So these are real life situations. I do have some case studies as well, talking about Twitter. And the second article sounds a lot like Facebook, but they call it a social networking site. So it goes on and talks about, okay, in these types of really large situations where you're dealing with thousands of pieces of data, but thousands of users having to hit it, and you're really, really concerned about performance, when does normalization make sense and when does it not? So it kind of goes through, especially the social networking one goes through and talks about, okay, in this case, duplicating the data and making sure that the data is consistent in 2 different places is way better than having to join in 12 tables to keep just those 2 fields in sync. Another thing to take into consideration is whether or not your data is really going to make any difference if it's out of sync. Sometimes it's very, very critical that everything be in sync instantly. In other applications, maybe it's not such a big deal. Your users maybe won't care if it takes 20 minutes to make sure everything's updated throughout the whole site. In other situations, like medical instances and things like that, banking instances, people get very upset if it's inconsistent. So you have to kind of gauge your users and see what are they tolerant of. Are they more tolerant of data inconsistencies, or are they more tolerant of performance hits and slowness? It's very, very difficult to always do both. So it depends on your situation. At this point, I'd like to pause just for a second and see if anybody has any questions. And I forgot to mention at the beginning, if you do have questions, we're supposed to wait for a microphone to come up. Anyone have any questions? Okay. So I'm going to flip back here to the table. So when we were talking about our fruit salad and our cheese display here and our different dishes, so we're going through and we have information about the dishes as well. Now this is third normal compliance. However, it depends on what your data is. We can split this out quite a bit further. And in these situations, we've only added 4 tables to this. But in a real situation, when you're dealing with user data, let's say you have a membership table. You're going to have their login information. You're going to have their address, and so on and so forth. One of the very common mistakes that people make with normalization is when dealing with addresses. So they feel like the address relates to the user, so you can leave it in the user table. But an address, the address itself relates to the user, but the individual fields in the address don't. For instance, the city and the state, for those of us in the US, or province in Canada and so on, it's different for every country, obviously. But those relate generally to the postal code, or depending on how your address is structured. So that's one of the major things that people miss when trying to be third form normal, is that they miss those small transitive dependencies and end up leaving more in the table than they necessarily should. Again, though, how often are you pulling out part of the address but not all of it? And are you ever pulling up the customer record without that address information? So that's the kind of thing you have to look at. Are we going to pull it up without the address information ever? If so, maybe it's good to split it out so we don't have to always pull that. But if we use them separately more often, or say a customer has multiple addresses, you can really get into a lot of tables quickly if you're normalizing, because now you have the customer record, which relates you to an address record table, which now has to relate you to a city table or a postal code table or a state or province table, and so on. And suddenly, you're ending up with 16 tables just to put together a street address. That's not necessarily a good thing. And so that's one of the cases where denormalization is actually very common in that situation with addresses, because of the complexity that you get into in those transitive dependencies to get to third normal form. Yep, don't forget to wait for the microphone. I'm going to try really hard to remember that.
I have a question. Before, when you showed the example of select star from table, and then you showed the complex one, you said something about using a view. I wondered, being an intro talker, if you could describe what a view is and how that could help in this situation.
Sure. So, well, it depends which database you're using, obviously. But like in MySQL or SQL, you can create an index or a view. And what the view does is basically you create the complicated query and you run that, and then that creates the view. And then now you can query that view table. So instead of having to do all of the joins every time you need to query that section of data, you query the view instead. I would say that's a basic definition. Okay. For those of you that don't know, Morgan works with MySQL, so I was like, oh great, pop quiz on MySQL right in front of Morgan.
Just trying to help you out.
No, that's good, that's good. Yeah. Any other questions? I apologize, I'm going like this. I can't see you if I don't do this. Okay. Anyone have any databases that they have normalization questions on? Any examples that you're wondering about? Any types of data? I hear some laughing. Hang on, just for the microphone, right up front here. Okay. Right over here in the red.
Hi.
Hi.
About the one value per field, what if your field is a set?
One of my fields is a set.
Now, what if the field type is a set? In MySQL, you have a set. It takes more than one value.
Right. In that case, if it's a set, it's kind of considered one value because it's one set.
Right.
So as long as you don't have multiple sets, I personally would consider that meeting first normal form, first normal form. However, there's sort of some disagreement on how to handle those kind of fields, especially, and it's not even just sets, but even if you're storing like an array of data in there and things like that, there's a lot of different ways to get multiple values in there, but it still sort of is one value. So it kind of depends on how strictly you want to follow it. Like I said, for my situation, I would consider one set to be one value because you wouldn't really split that out into multiple records, at least not easily generally. It depends what's in it, I guess. But the complexity you'd add to the table to get all of those and all the duplication you would add to the table to get all of those into separate records, I think outweighs the benefit of having fewer values in that field. So I would say as long as you have one set, it would be normalized. But again, that's my opinion. The problem with normalization is that there's a lot of opinions because it's easy to interpret things in different ways, and there's so many different types of data that can be stored and different types of ways to store the data. So you really get into some nitpicky stuff about, no, yes it is, no it's not, kind of situations. But like I said, in my opinion, I would say if it's one set in a set field, that's the data type that's supposed to be in there.
Thank you.
You're welcome. Anyone else?
I can comment briefly on the set thing as well.
Oh, good.
I agree with exactly what you said. I just wanted to make the comment that sets is a MySQL extension. So this is kind of talking more about SQL standards, and some purists that aim for 3NF, they won't use sets. So it's up to you if you want to take advantage of that enhancement or that extension or not.
Mm-hmm. Yeah, and like I said, I mean, for me, when I'm looking at things, I tend to look at what type of data is supposed to be in that field and whether or not there's more than one of that type of data. And so, like I said, with a set field, it's supposed to have a set in it. So if it has one set in it, I would consider that one value. So, any other questions? Okay. We're a little bit early here, but I'm going to give you a little more information about me. So you can find me on Twitter if you have questions. The slides will be available. They're not quite there yet, but they will be there very soon. So treelinedesign.com/slides. Again, I work for PHP Architect magazine. If you are interested in seeing the magazine, it's up here on the table. I'd love you to come take a look. I have a 20% off coupon if you are interested. Come and talk to me. You can rate this talk as well as all the other talks in the conference on Joined In. So the talk link for this specific talk is 10693. So feel free to give feedback there. If you'd like to give me feedback directly or if you have questions, this is my email address. Also, if you're interested in starting a user group, feel free to email me as well. And I'm not sure if people want to take a little break. I know there was really not much of a break between lunch and here. Feel free to sneak out. But otherwise, if you'd like to, we can keep talking about different types of data and how we would normalize it, if you would like to discuss that as well. Otherwise, thank you for coming to my talk. So. I apologize that it was a little short. Sometimes it's hard to gauge how many questions there are going to be. Last time I gave this talk, I had 45 minutes of questions. Had to cram everything into 15 minutes. So, yes, go ahead.
I don't have a question, but
Okay.
something that I want to say. Hi.
Hi.
I guess one of the advantages of normalization is to have a kind of single point of truth in a
Yes.
way. And it's just something that came up to my mind right now during your presentation is that after all, even if the database is not normalized, but while your team develops, they don't look at the database in a way, but there is an abstraction layer and a code API code that anyway presents a normalized access.
Yeah.
So that can be interesting.
Yeah.
Yeah.
Definitely. So single point of access for the database is another interesting way to handle this. For instance, Amazon is not normalized on their back end, at least as far as the information they've released. They don't obviously tell us too much about their back end, but they don't follow strict normalization on their back end. However, what they do is they minimize the risk of the data becoming out of sync by not allowing multiple points of access to the database. Everything goes through one point of access, and only that one point of access can make the updates. And so the updates get queued, so they only happen one at a time. And this way, they sort of mitigate that risk of the data being out of sync by only allowing access through that one point. So that's another way you can sort of denormalize, but still maintain the benefits of normalization.
Thank you.
Yeah, thank you. Anyone else? Hang on one second.
Is there a sort of general rule for, because basically normalised or non-normalised is really down to how many records you've got. So if you're talking about tens of thousands or millions of records, so is there a general point where you should only have 4 or 5 links if you've got, I know, tens of thousands, but if you're going into millions like Amazon, then you should.
Are you talking about
just
links
have,
between the tables?
Yeah,
or?
is there a general rule or?
Sure. As far as normalization goes, it's not really based on necessarily how many records you have, although that can play into it. But generally, it's how many times you have to access the database, because querying a large number of records is taxing on the database, but not as taxing as having to join, say, 20 tables 1,000,000 times a day. So it's a little bit, and we'll, yeah. So I think it's a little more based on that, but in general, they recommend normalization even if you have a few number of records, just because of the data integrity issue happens as soon as you have one record. So it's not necessarily how many records you have.
Totally agree.
Okay.
Just wanted to add some MySQL context. Some people say is that general rule you were looking for, normalize till it hurts, denormalize till it works. And you can actually get bad performance characteristics from either.
Yes.
A lot more people associate the bad performance with normalization. But if you're denormalized, to do a modification, you have to lock too many rows. And that can reduce your concurrency in doing that. So like everything in life, it's gonna depend on the situation.
Yep, so that phrase that Morgan just said, normalize till it hurts, denormalize till it works. So normalize all the way, and then see how bad it's hurting you, and kind of go backwards if you need to at that point, is generally the preferred method of doing it. Okay.
Just a quick question about fourth and fifth normal form, and just a quick, what's the benefits of those?
The benefits of those are additional stability. To be honest, I don't use them very often because it's a significant performance hit, I feel. When you getting to third is kind of a performance hit, but when you get to fourth and fifth, I feel it's even more of a performance hit. But it's a lot more dealing with the subject matter of the data. And generally with the data, that I work with, once you get to third normal form, I feel like the topic of the data has been segregated out enough for my purposes. But if you're dealing with extremely large record types, like tons and tons of data, huge amounts of data, then going into fourth and fifth can really help drill down to those specific topics and really pulling out, like when you need to make an update, you don't need to hit so many tables, kind of a thing, or you don't need to mess with records that aren't being updated is another thing. So you're not locking records that are not related to what you're specifically updating. Does that kind of answer your question? Okay. Any other questions? All right, well, thank you very much for coming. I will be here the rest of the slot just in case you have more questions, so feel free to come up and talk to me about normalization or the magazine or anything at all. All right, thank you very much.